Our first speaker is Aidan Hoyer. Aidan is the Superintendent of Operational Technology at Newcrest Mining in Australia, one of the world's largest gold mining companies. He's a professional engineer, over 10 years of experience doing basically everything automation related that there is, all right? He's got a couple of, 3 degrees actually, BS in Electrical and Electronic Engineering, Bachelor's in Computer Science, Master's in Utility Engineering, and of absolute necessity, he was forced to become an expert in alarm management, and he is here to tell you about that experience. So if you could turn on your mic, and I will turn this off and change the presentation. So please welcome Aidan.
Okay, well, look, thank you for coming along, and also, look, thanks for the opportunity to come and speak here. You know, it's a big thing, and also it's a long way to come, as you can probably imagine. It's about 24 hours of travel to end up here, so it's you know, it's a good thing from shows sort of how seriously Newcrest takes this sort of stuff to send someone all the way to the other side of the world to talk about what we've been up to. What I wanted to take you through briefly is we'll take you through a bit of where we started and where we ended up, right? So Newcrest Mining is, as Bill said, we are one of the world's largest gold producers. We own and operate mainly low-cost, long-life mines. So we look for places where we can go in and we can stay there for a long time. We are among the top 50 companies on the ASX and a market cap of about 15 billion. So we're actually a reasonably large company. You know, when you look at our operations here, we're really in this Asia-Pacific area. So these areas in gold are active operations. We have active gold mines. We only do gold. And we've also got some advanced projects in the blue there. So one thing to call out, you know, is the mission. Newcrest's mission is to deliver superior returns. But the vision is something that's really important. We're actually one of these companies where you see this vision everywhere. It's in every room. It's in everyone's desk. And people actually talk to this quite regularly. And it's to be the miner of choice. So that is recognising there are other people in the industry that do gold mining, there are other people that do what we do, but people would make the decision to go with us, make the decision to invest in us. So I operate at a site called Topher. This is Australia. For those of you who aren't familiar with it, you will see that there's a lot of it which is red and pretty much desert. But when you look at the population centre, so we've got about 24 million people in Australia versus, you know, about 325 in the US, but the land size is about the same. So these population centres here, Brisbane, Sydney, Melbourne, Adelaide and Perth, they're the places in Australia that have more than 1 million people. Okay, everywhere else, much less than 1 million people. So my site, Topher, is way up there, right in the middle of the Great Sandy Desert. And what we do is we truck our product out to the coast. So Topher Gold Mine's actually been around for a long time. It's been around from 1975 until 2000. It was a small mining town. It was active the entire time. In 2000 they shut it down, and then it became, they expanded it to a massive fly-in fly-out operation, and that's the way it's been running until now, so from 2004 onwards. There's around 1,500 workers on site, okay, so it's quite large. And we've got 2 open pits and 1 underground mine. So we mine these locations actively and then process it into a gold and copper concentrate. So we're doing about 22 million tonne per annum through our processing plant. But the whole thing is off-grid. So because we are so remote, we run our own power station, 132 megawatt power station with gas turbines. We do our own water, 60 megalitres a day of water coming in. All our logistics come out of Perth. So in the bottom left there you can see Perth. Takes about 3 days to get parts up. That's best case. Come in on a truck, and what we make, we truck out to Port Hedland. Then from Hedland it goes on to ships to our customers. The climate is the other thing that's something to consider up at Topher. We are in the tropical region, so we do get wet and dry seasons, which means it's either really dry or really wet. Summer, you can see there, I've done the conversion to imperial for those of you that don't use Celsius. But typical day in summer, you know, 47 degrees Celsius, and that is on the surface, right? If you go into on the mill floor, or for example, you go into the open pit where there's no wind and you've got all the heat radiating off the walls, it gets a lot hotter. So if we, you know, for example, if we have air conditioning fail in a truck in the open pit, you park up the truck and you leave it. You come fix it on night shift. Right. Winter, it's still pretty warm. And we also struggle with underground as well, because we have underground miners. It's not as hot under there. It's typically around 32 degrees, which is 90 degrees Fahrenheit, but it's 100% humidity. So to give you an idea, we've got 8 megawatt of installed chilling capacity. That is just for us to pump cold air underground to try and get it down to that level. So it's sort of, the elements are a bit against you, right? So the takeaway from all that, right, is you end up with these people up there, and you end up sort of doing everything, as Bill alluded to, right? You end up with people who are excellent generalists. If you're in the electrical engineering space, which is where I started, one day you'll be working on a massive gas turbine, and then the next day you're working on a light switch in someone's room, and then the day after that you're working on a sewage system, and then after that you're working on high voltage cables, and there's only 2 of you, and there's a lot, right? There's a lot. But it's fun though. So look, here's an overview of our processing plant, which is what I'm going to talk about today. We have a lot of automation running all the systems, but what I'm talking about is our processing plant. So basically, we have the three streams coming in. We've got our primary crusher coming in from one of the open pits, another one from another open pit, and then the underground ore coming up. You can see there's a lot of similarity. We've got 2 very similar trains. This is highly simplified, but the thing to take away from here is that we take multiple grabs at getting this gold, right? So it's hard rock mining. The rock comes in, we crush it up through a grinding stage, and then we get what we can easily through the gravity stage. And then we can't get what we can't get easily, then we have a whole lot of flotation. Can't get it easily out of that, we keep going and keep going to get as much as we can, right? So there's a lot of talk. You hear people talk about processing rates and kilo ounces of gold we get out and things like that, and it's really hard to visualize, so I sort of like talking about it in elephants. And so you guys kind of know the African elephants, the really big ones, not the small Asian ones, right? So they're about 5,000 kilos or about 1,200 pounds in weight. So what we do every year is we put about 4,042,000 elephants worth of rock through the front of the plant, and we get 2.5 elephants of gold out the back. So it's really low head grade, right? It's really low. The other thing that Topher is really known for, I mean, Topher is an industry icon in Western Australia, right? It's highly variable feed. So we don't get the same feed in. A lot of mines get 1 or 2 types of feed in. We pretty regularly get 12 different types of feed. So we're trying to put that through a plant. It's very hard to optimize the plant and also shift between these modes, right? And you can see from this, the other problem that we get in quite often is that we've got a lot of tanks here, a lot of flotation, a lot of it's sequential. There's no gap or there's no surge between that, right? So it's really easy to end up in a situation where you've got a problem here at the back end of the plant, and suddenly with all the recirculation that's coming around the front, then the whole plant's oscillating, the whole plant's going up and down, right? So it's a really interconnected system. So when you go inside the processing plant to talk about the control system, you can see a satellite photo here of our plant. We're Yokogawa DCS inside the processing plant. Everything outside the processing plant, all those ancillary services I talked about, power generation, water, underground mining, ventilation, all that's Rockwell. But inside the plant it's Yokogawa DCS, and we have OSI Pi Historian hooked up everywhere. Now, the plant is relatively new, which is nice. So anything you can think of, you can pretty much get in the Historian. We've got large vendor package equipment, which was the source of one of our problems, right? So when you build a plant, when they build plants like this, and I'm sure it's the same in your plants, you'll come in and you'll dump down a large bit of equipment and say, I want a 15 megawatt mill, please. And ABB comes in and says, very good, there you go, there it is. Puts their control system in and then ties it into yours, right? So we've got mills, we've got filter presses, we've got things like that is large package equipment, each sort of with their own way of doing things. And then we've got, it is a pretty modern construction, right? So it was at the time where everything is networked, which is nice. You don't have to go out in the field to do very much, but we end up in this situation they start to talk about where you get all this data coming in, right? Everything's networked, and because you can network it, you do. Because you can pull it back, you pull everything back, right? We've got pretty high levels of instrumentation and automation. So remember, Australia is, even though it's in the other side of the world, we're a first world country, right? So there's first world wages going along with that, and also flying people to the middle of the desert to stay away from their family for weeks. So one of the things we're actually really constrained on is human resources. Just getting the right people there and getting the number of people. And even if I had a magic huge, big pot of gold that I could hire people with, I've still got to get them on planes, right? I've still got to get them beds. I've still got to feed them. We're a whole operation, so we're really constrained on human resources. And it's a harsh process as well, right? We're mining and crushing really hard rock, so it's pretty common. We're shutting down sort of every 15 to 17 weeks, depending on how the maintenance is going. And we're replacing entire liners in mills and all that sort of stuff, because it just gets weared and worn and abraded away. So before we go on, the other thing as well is that a lot of our workforce, I talked about we have 1,500 people in our workforce, but any one time a bunch of them are off because people are rotating on and off, and also a large proportion of our workforce is actually out operating the equipment. So driving the trucks, drilling the holes, operating our 3 different mines. When you look at our processing plant, there's actually only about 10 to 12 people running that plant at any one time. So this was the problem, right? So we were about 2015. We had the control system. This is something I started looking after at that time. And the control system operability issues were largely resolved, right? So the plant had been upsized. We'd had this new plant in there. And all those sort of issues you get in a commissioning plant, you get that PLC shutting off because it gets to 70 degrees. So, you go and install new air conditioning, or you keep the filters clean, or all those sort of operability issues of just keeping the plant online had been solved. But we're running a lot of the time in a run-to-failure maintenance strategy, and a lot of that is driven by the high wear, right, and the equipment. And manual interventions in the plant are common. All right, so it's really common that if you open and close a valve from the control system, if it doesn't work, a guy goes down there with a hammer and hits it. Or we bend things a bit, or we chuck a hose in. Well, that sort of thing is common, and that's an accepted way of running. And we had a lot of reliability issues, so we had a lot of times where we'd have major production outages, or things would fail, or you'd repair them and then the day later the one next to it would fail. And we have a really good root cause analysis sort of framework and a reliability engineering team, and I'm sitting there in this team, and we do this again and again and again, right? We would look at why that bit of equipment shut down. We'd have all the information. We'd go back through our historians, we'd go back through our shift logs, everything, and we could see exactly the sequence of events that shut the thing down. We'd do a really big report, and then we'd put an alarm in, go, well, the operator should have noticed that, he missed that, clearly we need another alarm. And then a couple of months later, a similar thing would happen again, and again, and again, and again. And I sort of sat there and ended up sitting there and thinking, well, why is this happening? Who is this operator? Who is this magical person that's supposed to be stopping our plant shutting down, and why are they not doing it? And then you start thinking about all this stuff you're giving to the operator to do. It's quite a lot. So we went in and we did a back-to-basics approach. We actually went in and looked at the control system and said, all right, what is this mythical super operator? What are we actually asking them to do? And what are they really doing? So we went and had a look at the alarm system. Well, the alarm system wasn't even open. They weren't actually even using it. It wasn't even open on their screen. And it's not that this was a new thing. It had been like that since commissioning. We found that there was a lot of bulk configuration, and defaults were highly utilised, right? So we've got a lot of repetitiveness in our plants, right? We've got 72 odd float cells that are exactly the same. So configure it once, copy and paste. So there were a lot of errors there. Was no standardisation across packages. That big package equipment I was talking about, one's come from one vendor, one's come from another vendor. The way they do alarms, the alarm priorities, how many come in, they're all completely different. A lot of configuration errors, a lot of default on for alarms. That's one of the features. A lot of these DCS systems, when you drop a block down to configure something and start it running, you get every alarm turned on by default. And then, we had a lot of problems with instrumentation and maintenance overrides. This comes back to this sort of thing, if we can get it away, if we can bypass an interlock for a couple of minutes to get the pump started or the conveyor started or whatever it is, then we will. And that'll keep the plant up and running. And that was sort of the way we're operating. So to show you sort of what that looked like, well, before we go on, the result, right? This is the number, right? 100,000 alarms a day. This is what we're asking our operators to deal with. 3 operators deal with 100,000 alarms a day. And in reality, it was probably actually more. We don't know what the total number was because we crashed the reporting tools every time we exceeded 100,000 alarms a day. So we had a lot, right? So there've been a lot of workarounds done, right? So Bill's probably cringing about the lack of high-performance graphics here, so we'll ignore that. But what you can see is over the years, people had tried to solve this problem, but they've always tried to solve the problem with a local approach, right? We really, really care when our sag mill goes down, so what we'll do is we'll put in a little button. You can click that and you can see only alarms for the sag mill, right? Or you can click that one and see only the alarms for the ball mill, because we really care about those. And then someone would need another alarm, and we say, well, geez, we don't know how do we make the operator use it? Well, let's use the operator guide feature. Let's use the reminder for the operators, right? So this comes up. Hey, all those alarms you've ignored, now this one comes up in the center of your screen. And you have to acknowledge that, right? But it doesn't really tell you much. It just says, do some stuff. And then, those of you who are familiar with the Yokogawa system, there's a limit to how many of those you're in. So, one of the really clever engineers goes, I can do that with graphics. And at this point, this is starting to get a bit ridiculous, right? So coming back to, the what we do on site, we kind of do a bit of everything. One of the things that my team manages is also radio communications on site. So then we've got a great idea. What we'll do is when the really, really important stuff comes in that we really care about, we'll hack into the radio system and we'll make it play a sound. Pretty cool, right? Or what you really don't want to hear is this one. That's pretty bad, right? But so about this time we're sort of realising, all right, this is a bit ridiculous, and as much as we like engineering things, we're reaching the limits of what we can do here, right? So at this point we actually told them, you can only have 10. You can decide what they are, we'll make them whatever you want, but you can only have 10 voice alarms. And you should have seen the fights about that, right? There are a lot of fights about that. But what came through to me is that this became common in what people talk about on site. They no longer talked about alarms, they no longer talked about alerts, they talked about pop-ups. And you get a request through from a different engineering department or a maintenance department or someone, can you please add a pop-up for this? We didn't even use the alarm system. So I'm sort of sitting here and I'm sitting here with guys and we've gone and had a look and we've found all this sort of stuff. And then I've got a bit of a problem, right? Because we're sort of the only ones that are looking at this and saying this is a problem. So we had to bring this into the boardroom, right? We had to bring this into the people who have the control of the site and the knowledge and the ability to do something about this, right? So this is how I did it. These are the next two slides. This is what I went and actually presented to them. And I had to take this in the end through the safety side of things. Because it wasn't coming up through the normal engineering or the normal maintenance side. I actually had to bring this in and say, this is actually a safety problem. Got up in front of the manager's safety meeting and said, this is what we ask our guys to do. So what I showed them is this. This is Topher's recycle crushing plant. So to show them, this is what it looks like in the field. This is what you're used to seeing. But this is what you ask your operators to look at. That's the same. That's what your operator looks at when they look at a recycle crusher. And when they come in, they have these alarms, they have this alarm screen that they can use, and this is how they're supposed to know when something's going wrong, right? So I sat them there and I said, all right, that comes out, you're in there, you're running the plant, you're looking at these alarms up the top, and you use those 4 steps, right? So every time one of those alarms comes in telling you that something is wrong, you have to read the alarm, you have to understand the alarm, you have to decide on the correct action, then you have to take the action. And everyone was in pretty much agreement. That's right. That's what you should do with an alarm. That makes sense. They tell you something's wrong. They do that. Okay, all right, no worries. So all of you, you're no longer managers. You're now control room operators. You're now running the plant, and you sit down at Topher on your first day. Here's your alarm screen up the top. Here's what you see. You sit down, and this comes in the first 30 seconds. And you go, all right, no worries. I know what I have to do. We've just agreed what you have to do. So I'm going to read them. Blah, 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 blah. Train 2 primary crusher, truck detected on the right-hand side. Good, that's where they're meant to be. Train 1 chiller, common alarm. Well, something's wrong with the chiller. Well, I don't know what to do about that, but I'll see what's next. PU33, flash flow, PV, 4.3 metres cubed, litre now. Low, right? Oh, low there. And you can see as you read through these, right, I actually made them sit there and listen to me reading them. That I know what they are. You guys probably have a bit of an idea. You're not familiar with the plant, but you have a bit of an idea. But someone who's a control room operator is not used to seeing that at all. And you would have seen there, it just changed. You just got a whole new set of alarms. So I animated that in the real time. So you can see how far I got through them, and then there's more. And there's more, and this sits there, right, and it animates in real time. This is the same speed that we asked the operator to deal with the alarms, and that is exactly the alarms at the time that the operator was asked to deal with. So this was the point where they're sort of thinking, all right, maybe this is a bit unrealistic. Maybe we shouldn't go and beat up the poor operator when the sag mill goes down for not knowing why. Right? And you put these numbers up, right? 100,000 alarms a day, 4,167 alarms an hour, or 69 alarms a minute. And, I did borrow the phrase out of the book, it's, can you handle 69 phone calls a minute? You should have seen the eyes sort of roll, right, when you say that. So this is actually how we got the funding and the backing to do this, right? So one of these things when you're highly constrained is it has to really be the best next thing for the plant to do before you can get anyone's time or action to keep going. So when we actually started it, we took some really aggressive first steps. We just said there's no way anyone can deal with that. What we're going to do is we're going to suppress all system alarms. So if there's any alarm that tells us there's a problem with the actual control systems itself, suppress it. The operator no longer sees it. We also suppressed all non-control alarms, so all those nice warning things, reminding you to do things, just flat out suppressed them all, didn't even rationalise them, and we started addressing the bad coding in there. We started documentation and rationalisation and bad actor work together at the same time. So I took one of the control engineers out of my team and one of the operators, and I sat them together 1 hour every day, just look at the worst alarm and see what we can do about it. And really quickly what became apparent to us is we're not actually doing a control engineering job. Most of it was actually, what does that alarm say? It tells you the equipment's broken. All right, what have you done about it? We need to raise a work order. Okay, we'll raise a work order. And we're finding these things in the business that we had to go and actually fix, right? The guy who's the control room operator couldn't raise a work order. He had to ask his supervisor, and his supervisor had to believe that that was enough of an issue for the supervisor then to write the work order. So getting all those sort of things fixed, you're really doing more of a coaching sort of role. The biggest thing is stick to it. Newcrest has actually tried this before and not been able to get results. This is what it looks like over 3 years of work. So this is a log 2 scale, so that means that every time I go from one bar down to the next, I halve it. You can see 64,000, 32,000, 16,000, 18,000. And you can see the targets here. This is what we said we're going to do in a year. And it's still coming down, right? This is as of a couple of weeks ago. We're still not where we want to be. But getting it in there, just sticking to it every day and making that change, it will happen over time. And you can see that, you know, a lot of this came out of those really bulk aggressive changes up the front. This is before we even got the alarm management software in there, you know. If you have a substation, we'll have probably 30, 40 VSDs in there driving pumps. We'll pull back 20 parameters for each one. You know, there's 400 parameters coming back straight away, and then the comms link drops out every 3 seconds. You can get an alarm for every single one. So that's how we got that really bulk stuff up the front. So in the end, where we ended up, we actually re-engineered 665 alarm schemes. So the way we do an alarm scheme for a bit of equipment. We documented, rationalised 124,000 odd individual alarms. And this one is one that I'm particularly proud of. This one here, we got 233 engineering actions created. So what we did when we did this in the process, we actually didn't give the control guys the control philosophy. So we sat them in a room with an alarm specialist, with a senior operator, a control engineer, and we said, there's the process control system, go reverse engineer it. So when they wanted to know how something worked, they didn't go and read the control philosophy, which is how it should work. They went and actually looked in the system and found out how it actually worked. And so what we were able to pull out here, these are 233 projects that we found for other disciplines that we can't fix. So, hey, that pressure control looks wrong. Hey, I don't think the chemical addition there is right. Hey, we're missing protection for this state. So we actually, no, they loved us, of course, because we generated them all these projects, but we got all these other improvement ideas and improvement projects out of the process. And we also got confidence that we know actually exactly what is in our system now. So for us, this is really a first step, right? We've gone through and we've done alarm management in our processing plant, and you can see that we've got some really good improvement over time. And we've gone and done it in the other areas of our plant as well now, all those ancillary systems I was talking about. But it's really a foundation for us. You know, when you come in and you're going into a brownfield site and you want to make some massive improvement, you know, this is the first thing you want to do, is you want to see where the problems are. And documentation and rationalisation alarm management is a great way to do that. Once you've cleared that up, you know that what comes in is really what is really a problem. So we're sort of in this sort of phase here, in the repair phase now at the moment. We know all these alarms that are coming in are real. Most of what's left there, you see we're still around 1,500 alarms a day. Most of that is actually real equipment failures, real instrumentation failures, real high temperature, real high vibration in bearings. So we're going and addressing all that sort of stuff. And also now we can really tackle the improvement in the control loops, and that's sort of what's next for us now. Once you can keep it on and keep it in some boundaries, then you try and improve it. But there's all this other stuff we can do afterwards, right? All these other terms, and I'm sure you've heard of most of them and you're familiar with most of them, but you know, something that's still a constant battle in the site is someone comes in with a new shiny idea and wants to go and plug this on. We'll go plug some APC on, or we'll go plug some predictive maintenance on, or all these good sort of things, which are great things to do, but you need to have the foundations underneath. So we're still working up to that. So the lessons, if you sort of decide to do it yourself, just start. Really just start. It's a huge, huge long road, but if you start, you'll start getting some wins. You can't do it alone. This is a really big thing. This is why it sort of hadn't got traction previously inside Newcrest. You need to go and talk to the operators, talk to the maintenance, talk to the engineers. I was saying talk to the planners, you know, the guys who are managing your work orders. How do we get the right information to you to get it fixed in the next shutdown? You've got to go involve all those guys and get their help. You can get some good wins out of the maintenance guys as well, right? So if they're not used to using the alarm system, you can come in and you can say, hey, listen, I'm seeing high vibration on this. I think that's going to go out next week. And they get to swap over onto a standby or change it out before it becomes a breakdown at 3 a.m. You've actually only got to do that a few times, and that sticks in their head. They're like, oh, maybe that alarm system's good. Maybe we should use that. Maybe this guy's not nuts. So involve them. Follow a structured approach. Okay, so we used ISA 18.2, which is a really excellent standard. It's very descriptive, which is quite unusual for the standards that we normally deal with. You know, you've got a plan. You've got a reason to use consistent terms the whole way. Use the process, and you will get there in the end. Another big thing we found is losing the jargon. So when you first start doing this sort of stuff, or the guys that you know you're doing it already, there's all these KPIs you can talk about. You can talk about the number of alarms in 10 minutes. You can talk about your alarms per day. You can talk about flood, chattering, all these sort of figures, right? And the first thing we tried doing is sending that information to people. And you can create these beautiful automatic reports that go out, and you still have someone look at, you know, eventually they come and ask you, what was the top alarm for yesterday? And you say, well, the report's in your inbox. I didn't read it. I've got too much other information coming in, right, from everything else they have to do. So we actually took it down. That slide you saw before, that's the number I communicated to the business. Whenever anyone would listen to me for 3 years, this is the daily median number of alarms. So take a week. What was the median number of alarms I got for that week? So you can see that's highly filtered, right? Highly, highly filtered, but it does show consistent and continued progress, which is what people like to see. Things are changing and we're going in the right direction. Use the alarm management process to drive other improvements. That relates to the engineering actions that we pulled out of that. And walk the talk. Okay, sometimes you're going to be in there and you're going to be asking the maintenance guys to fix something, and they're going to come back and say, actually, that's just a really bad alarm. And you've got to sort of take that in the chin and go, all right, okay, no worries, we'll go fix that. That's our problem. Make sure it's not one way. And this concept of you're going to be a business coach more than a control engineer, this is something that's become more and more apparent as we go on. Actually helping people to understand what these terms mean, how they work. You know, we're primarily we produce gold and copper concentrate, but a lot of our resources, a lot of our expertise and what we're really good at is in mining. Right? It's in the traditional drill, load, haul cycle. We're not, most of the people aren't focused in this area. So coach them along, give them a hand. And it's not about optimization. It's really about the successful operation of the entire plant. Okay, we've got a case study coming out soon. There's some pretty pictures. That's our open pit. And it is actually really beautiful out there sometimes in the middle of nowhere. So does anyone have any questions? Yeah, so we rolled out shelving. About halfway through we rolled out shelving. What we found really fast is then the operators wanted to shelve everything. Because then they get 0 alarms and it doesn't beep, and that's really good. So that's something we're still addressing now, but that's that is a really good tool.
Did you also implement state-based alarm suppression, like when big piece of equipment is not working, you can suppress all the alarm associated to that equipment? If you're correctly configured with the DCS regarding hierarchy
Yes.
of plant, then you need the equipment level and associate all the alarms to that, and when that equipment is not running or down, then turn off all the alarms. Some of the pumps or motors when you're starting, then suppress those alarms for a minute to settle down, like workflow or pressure.
Yeah, that's exactly right, and that was key to us sort of sustaining those alarm rates through shutdowns. Quite typically you'll have a shutdown or your equipment goes off and you'll get a huge flood of alarms. So we'll use exactly what you're talking about, state-based alarming. If the equipment's isolated, the control power's off, it will suppress the alarm. So we can now sustain through shutdowns those low alarms.
One more question. Someone else? One more question? Yes, sir.
You just mentioned that you generate alarms on either equipment or instrumentation failure. Are you still doing that? And does that deserve to be somewhere else because it's not an operational alarm piece of
Yeah. So we are still doing that. What we've done is we had to have a maintenance priority now, and anything that's condition-based alarm, that is being pulled out to a separate list. So that'll be your high vibrations, high temperatures, things like that are warnings more for the maintenance team. But we will still get some of the alarms through for critical bits of equipment. If the valve's not in position, they will still come through the operator if it's critical.